Welcome to Slight Reliability, learning SRE one day at a time. I'm Stephen Townsend. Welcome back to Slight Reliability. I'm Stephen Townsend, and this is the show where we learn about observability and SRE 1 week at a time. Look who's back. It's Paige Cruz. And
it's me.
After last week, we talked about cognitive overload in the world of SRE. We thought we'd carry the conversation over. And today we're going to be talking about raising fluency in telemetry in the engineering world. And having established that, how do we get non-observability people interested and engaged in the world of observability? So, to kick things off, what does telemetry fluency? What does that mean to you?
Oh my gosh. Sometimes I think about the words we use in this space and I shake my head. We definitely have a penchant for academic terms. And when I think about raising fluency in telemetry, on the whole, software engineers are taught how to log. Maybe not how to log effectively, maybe not the benefits and the pros of structured logging, but generally, a software engineer joins a company and knows that they can spit out some text, some string to help them understand how their code is running in production. I think that is kind of the lowest level of fluency. So if you have nothing and then you add logs, that's great. That's one foundation. Going on from there, a lot of people's next step is metrics. And that makes sense because you can derive a log from a metric, like say, how many times did we see log user logged in? Count how many times of that, and then we see how many logins over a particular time. Where metric fluency, I think, could be raised is the more senior you get, the more that you need to care about how your designs cost the business in terms of infrastructure spend. And really, this year, a lot of people are already talking to me about their observability spend. And that really prompted me to want to have this conversation, because when I hear executives get nervous about the bill for observability, I imagine people taking like chainsaws to like the logs and the metrics and their traces and sort of in this really coarse way cutting out the most expensive places. When I think if we raise the level of fluency of our engineers to understand what is an expensive metric, what makes a metric expensive to emit or to store, or do you really need to have that 5-second granularity? Could you not pull for a metric every 10 seconds, 15, 30? There are so many little places within setting and emitting and labeling a metric that you can unknowingly blow up the bill. That I think that is one area for at least folks who are more senior in their careers. It would be a good time this year to start brushing up on what your spend is for your team or your service, and how you can trim that down, not taking the chainsaw, but taking more of a like X-Acto knife, like being very precise about where you are wasting money within your observability spend. I think the highest, I don't know about the highest level of fluency, but the level after metrics tends to be this world of spans and events. At the point where you are comfortable troubleshooting with logs, you have developed that kind of intuition or spidey sense of looking at these metric charts, developing really quick hypotheses. Oh, I bet it's the load balancer. It was the load balancer last week. I recognize this scenario. It all smells the same. That develops over time with operators troubleshooting with metrics. Traces based out of spans or events, it's like a totally different paradigm. What I'm trying to articulate is you can be very comfortable querying metrics and logs and finding your way around a system with that. But tracing and event instrumented systems are almost like a totally different level of things that you can query, like timescales, different parts of the system, even just send me all the spans that are over 5 seconds, like things that cross service boundaries, things that cross cluster boundaries. Like it is an area that is so new that I don't think we have widespread mainstream fluency with traces and events. It still feels like it is this sort of new kid on the block. Everyone's a little suspicious and side-eyeing. But I promise you, well, maybe I shouldn't make promises, but like I 100% guarantee add tracing and no downtime. It's more that you learn to inspect your system in different ways. And it should, when you introduce tracing or events, it should actually change your paradigm of how you troubleshoot. And that is it's a hard step to go from metrics and logs, I think, for a lot of people to tracing if you have a decade of experience with the former. The latter, I mix those up.
Yeah, I'm that kind of person. My performance engineering background was logs and metrics.
Okay.
Weirdly, I would manually troubleshoot and bottlenecks by almost trying to create traces from various logs and pulling the information together. Yeah, if I'd known more in those days about the tooling that's available and just the approach to it, I would have done things differently. A couple of things I thought of while you were talking about it. The first one was about metrics. I think from my experience, most sort of enterprise organizations that I've seen don't actually do custom metrics. They install like Prometheus, like a Prometheus exporter for something. Yeah. And just every single metric, it just gets dumped out of it. They just keep it all. And I bet you, I guarantee you a lot of cost is because it was just so many metrics that no one will ever need or care about, which are being stored. Whereas my inclination, whenever I have an exporter like that, is to go, you know what, I'm going to block everything and whitelist the things I do want. That I'm because of being thoughtful about, I want this metric and this is why. It tells me this about the system. Because everything else is probably irrelevant. That's my inclination anyway.
Oh, totally. Having an intentional, holistic telemetry strategy, like if people could just have one initiative this year, that is what I would advocate for. Because you're right, it's the dark side of auto-instrumentation that I don't think people like to talk about. It is absolutely lovely that you can slap on a Prometheus exporter and get insights into your infrastructure components. That is obviously working for everybody, but why do I need this metric? If you had to justify all of the metrics that you were forcing your company to save and store and pay for, like we would see, I think, a drop in how many we were willing to accept. I agree with you.
Yeah. Okay, that's really cool. And the second thing was around traces. I think when you get to the traces is an area that I'm going to be spending a lot more time looking into this year. Obviously, it makes sense to me. I understand the concept. It's the kind of stuff I used to reproduce manually because you have to. That's the only way to understand what's going on. But it's not the kind of thing an individual or even one team can necessarily implement by themselves. From my perspective, it kind of sounds like it needs to be like a division or at least a whole solution or maybe an entire organization needs to kind of agree on some things to make it work. Is that true?
Yes and no. How's that for an answer? It depends. I'll use every principal's favorite answer. It depends. So I think when you're in a large organization, it will always be an easier path if you have executive support or you have the support of whatever team is in charge of the monitoring or metrics piece. It is always going to go better if people up top agree that this is something to focus on. A lot of people, though, work in companies where that is maybe absent or it is not a top level initiative. But if you're an operator that is very, very frustrated with a low observability system, what I like to say is, you can add tracing for just your service. And I think of that as totally equivalent to adding APM. Like, yes, is the idea and the vision of a trace the end-to-end request bopping through every component in your distributed system? Yes, wonderful goal. Is it still helpful for you to be able to trace a request within one service and maybe see the outbound spans to third parties? Yes, I would argue yes. And it's got us. Hold on. I think I have a quote about this somewhere. I should find it. But it's like, lighting one candle is better than complaining about the darkness. And I'm like, that is it, right? Like, light the first candle, bring the visibility to you and your team, and like, make the case. The other side of the coin is there are companies that have implemented some level of tracing and aren't getting the ROI out of it. The common denominator I have seen from that is it is sort of the auto-instrumentation problem. Okay, I give you a dashboard that has all your Kubernetes metrics from prom. If you didn't instrument to know why those metrics were needed, how are you supposed to interpret and understand the usefulness of each of them? And I'm just a telemetry nerd. I always go check out what is being emitted. How am I supposed to interpret this? I don't want the first time I see a metric to be in the middle of an incident. So yeah, I don't want to be like, you can have it all, you can have your cake and eat it too. Any way that you implement this tracing is going to be good. But I do think you can have value from it, even if it's not end to end implemented. How would that have worked for you?
I think that could have been a good approach, especially if there was a team who wanted to be more observable. Then they could also take what they've done and then demonstrate that with other teams in the organization and get buy-in. I think it's a good way to prove something out in the real world and say, we're doing it. You want to do it too. It'll all work together and it's better for everyone.
Yes. And you're right, it is always best to start with the team where you've got some champions, where you've got some fans of monitoring. There's always a few in each organization. Definitely starting with them is the way to go, not the detractors. Let them be convinced by your awesome results.
We took some notes the other day on fluency in different areas of that. One of the things I think you mentioned was understanding at a high level the life cycle of a metric, log, a span, or event. So could you give me an example of what a life cycle might look like?
Yeah, and this comes from me trying to introduce observability and getting more engineers to adopt the monitoring tool at previous companies. And the issue was people wanted to know, why isn't this metric showing up when I add XYZ? And I'm like, oh gosh, that's a really good question. I could go on my own, off in the corner, troubleshoot this, put in a PR, fix it, and then tomorrow you would come in and that metric would be emitted. That, to me, was not a good outcome because I guess I wanted more people to understand how this stuff works, so it wasn't this magic black box. I don't like magic black boxes. This is all technology that should be understandable. And so at a high level, whatever your system is, to be able to say, your service emits this metric. Maybe in the case of some of the agents that run in your Kubernetes clusters, maybe there's like a master agent that is picking up that metric, annotating it with, hey, it came from this Kubernetes pod on this Kubernetes node. Here's our versions, and then sends that off to your monitoring system for the backend. It gets stored, and then you can query it. Just knowing those hops and where you are auto-instrumenting or adding those annotations. Maybe it's just knowing that your company has a custom internal library for logging that will add in automatically the team name and the tier of the service. And that tier of service is tied to how quickly SRE answers your tickets. Like, to demystify those pieces, I think makes you a more confident instrumenter. You know what you're doing. You know when you add a line where it's going. That is also a place that for those senior folks, you can say, by the way, here is a really expensive way to do this, and here's the cheap way. We would like you to use the cheap way, but we're showing you this other way so you know not to do it. And that's a lot of the conversation around metrics cardinality. How many unique things are you having to store in a data store somewhere? But whether it's a metric, whether it's a log, whether it's a span, I think particularly for tracing, folks don't trust it yet. And especially when you bring up sampling, like, okay, we're sampling only 1% of all of the spans or the traces that we see. People hear that and you think, oh my God, there's no way 1% is a representative sample that if I click on a trace, I'm going to understand what's up. When in actuality, when you uncover the math and you look at it, depending on your strategy, you totally can trust a 1% sample rate. And it is just this, like, it's kind of like the fear of the unknown or the distrust of the unknown. And so peeling back that high level of what you, the operator or the engineer, instruments to where it shows up and you can use it to troubleshoot, that I think should be a part of on-call onboarding. Recently,
I talked to Ken Hamrick from the Trace Test open source project.
Yeah.
Just out of curiosity, I'm guessing that there's a way you can say, I'm going to fire an API call now, and I want you to keep this trace, please. I'm guessing there's a way you can flag that and say, please keep this.
Yes. At least within Open Telemetry, there is an always on or an always off, which I was like, when would you use always off? And I thought maybe, if you didn't want to emit, if you only wanted to emit spans in like your dev environment or something, I don't know. But always on is what you are talking about. Like, do not ever sample this out.
Oh, okay. So you can't send like a special header or something that says keep this particular span.
Oh, so when would you want that in particular?
Say in a test environment where maybe in the same environment you're running load tests, which you don't want to keep every single one because it's just too much data. But you've also got sort of functional testing happening, and for each of those, you definitely want to keep them all because they're going to be checked against. Someone's going to go and check them.
Okay. Yeah. Okay. So in the case of like maybe running some CI tests or running some load tests to be able to have something normal to compare it to or a good to compare it to, yeah, then maybe that is a great case for always on. Always on in production a little bit scares me, depending on the throughput of your system. But yes, that is possible.
Yeah. The second thing that we talked about with Fluency is understanding architecture and software design. Now, I don't know. I'm not going to make guesses about how fluent developers are generally about the wider architecture and how each service fits together with others. Is it common for developers to understand the full picture of their service and components and how they interact with all the other ones across the organization?
I think more and more the answer is no engineer, regardless if they're a software developer or an SRE, is able to construct an even somewhat accurate mental model of all the boxes in production. That is why I particularly love one visualization that tracing gives us. And to be fair, I do not telemetry shame. I have room in my heart for every data type. Like, they are all valuable in their own way. I'm just really excited about tracing because I think tracing needs a little bit of love, being the newest entrant on the scene. But I like to think of, a lot of people look at a trace in the waterfall. They look at one trace and that's the waterfall diagram. Or if you're a front-end dev listening to this, first of all, one, good on you. And two, think about it as that network waterfall that you see in Chrome DevTools when you're inspecting requests. So that is one very helpful way to understand what the heck happened for one particular request. My favorite actual visualization is the service or dependency diagram that you can generate from looking at a lot of traces flowing through your system. What boxes talk to what other boxes? You can track the throughput between them and see the error rate, all of those sorts of things. It's really helpful to have it overlaid on that like service overview topology map, because I see it as a living, breathing architecture diagram. It is the reality of what is happening and where traffic is flowing in your system. It is not dependent on you having worked at the organization for multiple years, building up your mental model as the system grew. No, anybody could walk in and say, oh, this talks to a data store. Oh, there's a cache over here. It's like looking at a map. I don't know. It's probably the coolest thing that tracing can do for us, I would say.
That does sound super cool. And so it's kind of like a node graph almost of all the bits and pieces talking to each other. And that's really cool.
Yeah, I would like to see more applications of this in the documentation space, say, because I don't know about you, but when I would onboard to systems in a pre-tracing world, trying to get someone to give you an up-to-date system overview, diagram, talk, introduction was like pulling teeth. Like, it was really hard to get anyone to agree to do it, let alone say, okay, I'm 98% accurate that this is the truth.
For 10 years as a consultant doing performance testing, that was the first thing I would do. I would go and talk to people and say, can you explain your solution? And inevitably, there would be no diagram, usually. And so I would get bits of information, draw it together, and show them for the first time. This is it. So what you're talking about, it just happens. If you've got the telemetry in place, when it's observable, it just happens.
Yeah, and I think of it even as a really great place to understand the cross-team dependencies. When I was working on a team that was a part of not the ingest layer, but the data analyzation layer that happened right after we ingested, there was so much overlap and talking I had to do with the other team to know when was their service ready, when was it going to be on, when could I access this API endpoint. And I would have much rather just been able to walk into my monitoring system, see when it was turned on, and go about my day instead of having to talk to these humans. And not that talking to humans is bad. There's a lot of insights that I think you probably gleaned from interviewing those developers to ask them what they knew about their system. That is revealing in and of itself. But I find it very low value communication to constantly ping someone, hey, is this thing deployed yet?
I agree with you there. And communication overload on low value things. Yeah. We also talked about having, as part of the Fluency, having an understanding of the infrastructure or the platforms that the code is running on. I think you don't have to go crazy. Like I don't think that if you're a person who writes code predominantly, I don't think you need to be a deep Kubernetes or, AWS every single resource expert, but having some level of understanding. I mean, if using Kubernetes as an example, you're going to get these sort of standard metrics generally that come out, and they're not like a OpenTelemetry or a Prometheus thing. They are a Kubernetes thing. It doesn't matter which monitoring tool you use. They're the same metrics coming out, right? So being able to understand what those key ones are, which are going to tell you about, maybe the 4 golden signals or those key things you care about, at least is important.
Yeah, that is, I think, the $1 million billion question also of this year is what is just enough platform knowledge? What is just enough Kubernetes knowledge for a developer? I mean, I've been doing the SRE thing for way longer than I was ever purely doing software development. And so a lot of my insights are colored by that. But I think probably pod level metrics are going to be the bread and butter that app devs should be looking at. You should understand what a pod is and how your container that is running your service relates to it. I don't know that you need to go much more beyond that. I mean, the reason I ended up in SRE is because I kept asking, well, okay, but what happens when it gets deployed? Well, I'm not satisfied with just having a screen that is showing me my container metrics. I want to watch it get rolled out. I want to know what's going on under the covers. And so I followed that passion or curiosity into the whole SRE field. That is not something that I would expect developers to do. I think maybe the more senior you get, you should be more aware of at least how you should scale your system within Kubernetes or whatever platform your company is cobbled together. But knowing when to call an SRE and ask for help is probably the best thing you could do no matter your level. SREs would love to be asked proactively how to address problems. That's probably one of our favorite things to be asked. Not as fun to be asked after the fact and after things have blown up. So as far as what's enough, yeah, understanding pods, understanding crash loop backoff, I think that can be a very mysterious metric. Okay, I got an alert that my pod is in crash loop backoff 15 times. What does that mean? Well, it really means that it's tried to start and it couldn't, and it's really like a restart metric. Okay, is that configuration? Was that the infrastructure not being ready? There are so many reasons for it, but if you're not familiar with that pod level metric, what it means, crash loop backoff, you instantly think, oh my God, it's a Kubernetes thing. I'm going to go talk to the SREs or the infra team. And it's oh my gosh, no. It's actually your thing and I'll help you troubleshoot, but ball's definitely in your court, bro. So that's maybe one tactical example of something I think developers could take a little more ownership of. But of course, they need to be supported and educated by their SREs and their infra team. It's definitely a shared responsibility.
I think as part of Fluency, it's also about, and this is particularly for metrics, because logs, traces, that's raw data. This is an event, it has occurred, and here's the information I have about it. That's one thing. Metrics are, this is a number which is aggregated across a bunch of events, and what does it mean? And I think it's very easy to misinterpret what that means, especially, averages and percentiles. Things like just CPU usage. Maybe you're tracking CPU usage, just average. That's fine. Average CPU usage is fine for a metric. But if you're capturing CPU every 5 minutes, then what is that telling you and what is it not telling you?
Yes.
Maybe your server or pod or whatever it is was 100% utilized for a minute and your customers couldn't do anything, even though it says, but it's 20% on average for the 5 minute period, being thoughtful about sampling intervals, what metric to use, like using percentiles. People go, I'm going to use P95. Why? What does it tell you? What is it not showing you? What are those 5% outliers that aren't being shown? Because if 5% of requests are taking 4 minutes, is that good enough? Well, I don't think so.
And who are they? Is that 5% your biggest customers who generate the most revenue? That would be 5% worth solving. Or is it just a bunch of random people and, they're new users you've never seen? Like, oh yeah.
Yeah, I miss one thing about performance testing analysis was having raw data and lots of scatter plots. And I know that's impossible in big complex systems with, trillions of requests going on. But in most organizations, like I know for a fact in my previous roles, it was possible to have access logs, for example, of every single request hitting a production server, and we could keep that for years, and it wasn't a big deal to store that. That's amazing. And being able to plot that and see the actual pattern of behavior over the day and over the months and how it changes, it's really powerful. And we don't utilize that in SRE much that I've seen.
No. And on the audit log piece, sort of that ability to dip into everything, I think that is the value of at least trace-based metrics. I like that if you choose the right sampling strategy, the metrics you derive from traces are 100% of the choices or the spans that have gone through your system. That makes me very happy. I get a little nervous when I hear aggregation, but that is my baggage from coming from the enterprise observability world, where you do not think really about how you are aggregating or downsampling. You kind of install an agent, you decorate with the attributes and the data that you need for your business, and you kind of go along your day. As I have been inducted into this Prometheus world, I am like, oh my goodness, I cannot believe people are out here picking their time intervals, picking out when they're going to downsample, like how they're aggregating. It feels like a lot of people do it on vibes versus on like pure stats. And I get it, because it is very complicated to weave all of this together into a statistically relevant data that you can depend on. Because I watched the stats experts and wizards at my company puzzle over this, and I know not everybody out there has got like their PhD in stats. So an average CPU also kind of bugs me because the example I like to use is I logged into my student loan payment portal and it said, your average interest rate is 6%. And I'm like, who is that average for? Like, in what way is that relevant? Because I, the user, like logging in, I actually care about the real interest rates attached to the real loans. And it turns out like most of mine were 7%, and then I had a couple 4%. As someone who's trying to pay that off with like a sane strategy, the average made no sense to me. And like, how would I use that? And similarly, that's kind of how I think about our average metrics is like, who is that for? And is that a valuable like aggregation method? I don't know too much about the min and the max. I always like to look at those in addition to the average just to see how the average tracked against those. But yeah, not a fan of averages on the whole. And I think something that shocked me about the downsampling metrics is at least what I have learned with the time series metrics, when you're looking at a chart on a screen, you only have so many pixels to display this data. And the bigger your time window, so maybe you're looking at a chart that's 1 hour and it's broken up into whatever, like 5-second buckets. The UI engineers are going to kill me. They do this math all the time. But like, okay, cool. So you have this box and it's looking at 1 hour. You zoom out to 1 day. Okay, you're trying to fit a whole day's worth into what you were just showing in that same box for 1 hour. Now you want to go back. You want to look at a week, a month. You're getting greedy, wanting to look at this historical time. Well, in other systems that I've worked in, downsampling meant that the longer we kept your metrics data, the bigger a bucket we would put it in because it's cheaper over time. That means when you were looking at 2-month historical metric chart, you're looking at a coarser grained time interval bucket than you would be at a 5-minute, last 10 minutes chart. And that is something I don't think many engineers are aware of when they're messing with the time scale and zooming in and out. And it's just one of many things I learned about why I love paying other people to do monitoring. And nobody should build, I won't say nobody, but building monitoring stacks and operating them in-house is not to be taken lightly. How about that?
Yes, agreed. But on the flip side, it is frustrating when if you're using a particular tool technology and you know what you want, but you can't do it because it turns out the data's actually been aggregated away to oblivion, and I can't actually see a year ago what the daily for this was because it's been aggregated to a week or something.
Yeah.
I don't know.
Do you think that feeling, that frustration, is unique to engineers because we are like, I know what it could be and I could build it, or do you think a lot of users of technical systems find themselves wanting to redesign it?
I'm not sure. I think it's a particular kind of engineer who has an interest in getting numbers right. For me, the biggest use case was in the performance engineering world was workload modeling. I wanted to understand what is the historical usage on a system and how is it going to change, and to predict how it might change in the future or what normal looks like today. And I'd want to go back years because you want to see, hey, it grows 20% a year, and here's the fluctuations day by month. And I want to see at least day by day, ideally hour by hour, because that, and most of the time I wouldn't get the hour.
Man, oh my gosh, yeah, because the seasonality can really change depending on day, week, month. That's a great use case, workload monitoring. Did you find that companies that had big days, say like, tax season for tax software or Black Friday, did you find that those organizations did have at least historical data for that particular time period, like that week or that month?
Sometimes, yeah. And that was the big use case for retail in New Zealand. It's not Black Friday, it's the day after Christmas, Boxing Day. That's our big sales
Boxing Day. Yes, yeah. Y'all and the Canadians, I think, do Boxing Day.
Yeah, so we'd always be modeling Boxing Day. Yeah.
My theory is I've worked at companies that have those big, like, oh, we're prepping for this once a year, big push. It's the most high traffic day. And there's a lot of energy that gets put into preparing, being resilient, scaling out for that. And then the rest of the year, you kind of like are not focused on it. It's kind of business as usual. And my hypothesis is, I bet there's some really interesting data, actually, if you were to keep that fine-grained, hour by hour data outside of the peak period. I bet there's all sorts of interesting usage patterns going on that you would find if you kept the data. So I guess my question was, do you think that hypothesis is sort of sound?
100%. So there was a retailer I did many, many years of testing for. They were most worried about Boxing Day, but I would do the whole year to see what does normal look like, because it turned out they needed, 10 times the infrastructure on Boxing Day than any other day of the year. So they're like, well, maybe we don't need the same, we need to scale down our infrastructure for the rest of the year. Even when they were running promotions, they would be like, big promotion, big sale. It would be, a fifth of what they would receive for Boxing Day. So it's still, and so that's helpful knowledge because you can save costs on infrastructure by not having that information.
Yeah. Oh, totally. And yeah, I guess I just want everyone to work within highly observable systems because what I feel when I go to a monitoring or observability tool is, I think I've said it before, like I feel like I'm going to a treasure box. I'm so excited to dig around and see what gems of insights that I find. And whether that's, oh, wow, did you know most of our traffic comes from mobile? Like that surprised me at one company when I had really purely focused on the web experience. I did one query and looked at, the source of our traffic hitting the CDN and was like, good God, it's all mobile. Why are we not pouring SRE resources into the mobile team? Like they're bringing it home for us. So this is a little bit of a segue into our next question or next topic, but I think stoking that curiosity in folks is a great carrot to dangle to bring about better observability practices.
And that's the kind of thing that stokes the curiosity. Hey, did you know that the vast majority of stuff is going through the mobile platform? Oh, that's really interesting. As opposed to, hey, look at these 400 default Kubernetes metrics.
Yeah.
No one gets excited about that.
No, they're not. I've tried. I've definitely barked up that tree. And it is that curiosity of, did you know you had access to this? Or even honestly showing some cool visualizations. There's everyone's used to the the bar chart and the line diagram. But a lot of the charting tools these days are coming out with heat maps. They're coming out with, okay, click on this. There's like service diagrams, again, like based on, I believe, tracing data, where you can click on that and then be taken to the logs for that service. Like, we're really moving past the dashboard or the chart as this static, refreshed every so often piece of data into really a modern observability tool is quite explorable. It should enable you should be able to, like I say, click like a fool on the page and be taken to other parts of your system.
A little bit of a segue,
Yeah.
but we're experimenting at the moment with the idea of diagramming and connecting. Like, you can just draw a diagram and then connect the things you in your diagram to actual telemetry data, so that it changes the diagram in real time. I think that's really cool.
Oh, I love that.
I like the idea of sort of like storytelling, the way that you want to tell the story with real live data.
I think that two-way sync is very compelling. I think of also, when I first started using Terraform, I was obsessed with the .viz graph that you could pull from it. I had a lot of notes about how it would make a very horizontal, the bigger your the infrastructure you were modeling was, like the wider the view would get. And so it wasn't as helpful as it could be. But I always thought, gosh, why are we not including the real-time infra diagram when that data is totally there? And for most humans, that is infinitely more understandable than blocks of HCL. And it's not a knock on HCL. Like, they're doing the best. Like, they've come leaps and bounds. But like, I was reading about why are we humans so fast with visual implementations of data? And it's because it is part of our brain that's really old. And the really old parts of our brain are like the most like primal and like quick instincts. And so it's something in our brain called pre-attentive processing that is like so fast. We process visual data so fast, we almost can't measure it. Like, that's how quick it is. And so really, when I think about how do you show the value of observability, or how do you get people interested, it is showing the trace waterfall. It is showing the service diagram. And, oh, look, you can click on this service because it's red and it's alerting and you want to know more about it. Click on the thing that you naturally would want to click on. If you were if you were a child looking at this, you would just go right there. And so teaching people to, it's never fun to be paged, but like, to teach them to have, fun isn't the word. I find it fun, but I know that I'm an anomaly here. But to teach them that you can interact with your observability tooling in a way that wasn't really possible before, when you were having to manually stitch together the sequence of events that would tell the story, that today you can get not for free, but today you can get by looking at a trace.
In the wider sense,
yeah,
I still think we've got the situation where there are observability people like you and I. Obviously, we care about it, and then there's the 99.9% who are engineers doing other work, and it's just not on their radar. And we can get people excited about it, but how can we make it easier for just engineers who maybe don't know much about it to get involved? Like, I've thought, well, one thing is about the frameworks that we are setting up a framework so that there's no need to go and install, because the libraries are already imported or automatically, and then I don't know, what else can we do to make it easier for engineers to use it?
I looked it up. That is the $6 billion question. That is the market cap of monitoring. So I have tried to tackle this a few ways. I think, as far as developers, setting up a collector or an OTel collector or whatever monitoring system you use, being able to locally develop an instrument and send it to your local collector, your local whatever, and then get that visual, that takes the feedback loop of opening a PR that adds instrumentation, going through PR review, getting it merged, deploying it to each subsequent environment. And then finally, when it hits prod, which is really where you want to see it do its thing, that could be on the order of hours, or unfortunately for some people, days of a feedback loop. And that is Nobody's happy with that. Like nobody is feeling the joy from a 3-4 day long feedback loop. So I think if you were to start anywhere, oh my gosh, get your monitoring set up to be able to run locally for all the teams. That does mean having language and framework specific configurations available. It's not good enough to say, oh, just run the OTel collector in your Docker Compose. Like, definitely that's where you want to roll out the red carpet, is in a local dev scenario. So that's the first thing. When you were doing perf engineering, were you running stuff locally, or were you always working in an other deployed environment?
We were always working in deployed environments because most of the time the focus was on not just individual components, but integrated systems.
Aha. Okay, that makes sense. So yeah, the local dev thing would not have really applied to you. But I think for an app dev and software engineer, closing that gap of you add this line, see how it shows up, because instrumentation is not like second nature for folks, or sometimes you realize you misspelled the label you wanted to add, and like it's really annoying to have to open a PR up for that. So that's the first thing. I think generally stepping back in any education and enablement you do, breaking it into two pieces. One, the foundational concepts. Setting an alert based on a metric threshold. You do not have to tie that into a specific OTel, Prometheus, whatever. Separating the broad monitoring concepts and then backing into, okay, at this company, we use Prometheus, and this is how you tactically set that up. But I think a lot of people, even like some seniors and some architects I know, like unless you really worked at a company that took monitoring seriously, it is a gap for some people, and they may not feel comfortable showing up to a monitoring 101 class, right? But maybe if you pitch it as, okay, we're going to up level our observability this year, we're going to level set, here's what compounding alert is using multiple metrics, like that gets really complicated fast. If you separate the concept from the implementation, I find that people get it more, and you won't have to get into those debates of, like, people are very passionate about like Prometheus or not Prometheus, and oh, it should be this way, and oh, you're polluting the context in Go. And I'm like, all of these decisions are above my pay grade. I'm just here to help you get it right. Like, I don't want to debate this stuff. Like, what's done is done.
I hate to say it, but I think fear is a great motivator.
Oh, yes. Okay, tell me if you agree with this hypothesis. I think an organization does not begin to take reliability seriously, with the exception of a couple industry verticals like banking, where it's highly regulated, unless they have the big one, which is the incident that is big enough to get the C-suite to be afraid.
I think what you just said is correct. In a lot of situations, which is unfortunate. But I do think, I was kind of thinking from another way you could put the fear in a good way, is to say, you know what, hey, delivery team, you build it, you run it. You're on call for this. And that, I think, is a lovely motivator for observability, because obviously if you can't see what's happening, how can you understand if there's a problem and how to fix it if there is one? And
the you build it, you run it, I'm so on board for. Nowhere have I worked has it been quite the right balance. I would say it feels like SRE takes on a lot more of that. Kind of you build it, we run it is what I've been accustomed to. But the one thing I do love from the Google SRE book is they're like, we don't just give SREs to anybody. Like, also, SREs can decide to like dip out of a team if the team is not meeting standards. So I like this idea of you build it, you run it, but maybe SRE or some central team is saying, we expect that you have this type of logs, and here's the logging library that we provide to you, free of charge, just import it at the top of the file. Or we'll give you red or golden metrics dashboard, and we'll even make a video walking through explaining what each of them means, and we've made a dashboard that's filtered just to your services, just your regions and whatever. But then having the ability to say, no, you don't get SRE support unless you meet minimum documentation standards and minimum monitoring standards. That is the world I'd like to live in. But I don't know if that's quite fair, because as we just talked about earlier, we've got devs that are mystified by pod metrics because they're just shoved a Kubernetes dashboard and said, this is your service health. Use this. So there's a bit of a gap that we have to bridge to get to the you build it, you run it, I think.
Definitely a two-way relationship. It's like I'm going to I'm happy to look after this service for you if it's easy to look after, but I have to teach you what that means first. Otherwise, how are you going to know?
Yeah, and again, like SREs are not superhuman. Like if you are lucky to have tenured SREs who have seen it all, who worked in data centers, who've like really been around the game, who know their way around tech stacks and have lived through many tech hype cycles, then yes, they can totally seem like superheroes who you can call them no matter what team you're on with whatever problem, and they can kind of get you unstuck. But that is a very outsized responsibility for one role, and it's highly dependent on having someone very, very experienced with multiple different tech stacks. I think it is a lot more realistic to expect that your app devs have, what does this service do? What's the most important, like API endpoints? How is this related to customer usage? Like, otherwise, I don't know how folks expect people to like grok that stuff,
Is there anything else you wanted to cover on the third point, establishing value? How do we get people invested?
Yeah, I think one, I would like to invite everybody to join us in this world of open source instrumentation. Open Telemetry is, I think it had like some of the most active contributions last year, right behind Kubernetes, if I recall correctly. And still, I hear people talk about, oh, well, OTel hasn't delivered, or why isn't logging there yet? And I invite everyone genuinely, not sarcastically, to please join us. It is going to take a lot of people to get this off the ground and get this deployed everywhere. And my dream is instrument once and never frickin' again. Like, that is what I want OTel to be for everybody. And you don't have to be an observability expert to join. There are so many different ways to get tapped in. So please check out over on CNCF, join the Slack. There are plenty of SIGs with friendly folks who would love to bring your contributions in line. So I think, the first thing I'd say is please join us. It's going to take everybody, and it is the most durable, marketable engineering skill you could have today, is being a whiz with monitoring, alerting, and observability. It has carried me very, very far. And the second thing I'll end on is, if you do want a pretty generic book that just talks about monitoring and observability concepts, really doesn't get into technical implementations, it is an oldie but goodie from O'Reilly, Effective Monitoring and Alerting for Web Operations. That book, it does what it says on the tin, and I highly recommend it.
Thank you once again, Paige, for absolutely fantastic conversation. I thoroughly enjoyed it, and I really think people are going to get a lot out of this. And we may even see you back in the future to talk about open telemetry, if you're interested.
Yes, anytime.
That's all from another episode of Slight Reliability. I'll see you all next week. Hopefully your pages don't beep too much over the next week, and you have a good time. See ya.